Hello everyone, welcome to Payment Tech video. This video is a quick recap regarding subnetting. So as we talked about previously, basically breaking a large network into the smaller network. That's subnetting. Why we need to do that? Again, there are so many reasons. One of the reasons is because of security reason, let's say. Another reason, it could be better management of the network. Another reason, not to waste too many IP addresses. So in this video, we will go over one example of subnetting looking at Class B address. Let's go ahead and jump into my computer and take a look. For example, when we have the IP address of 172.16.0.0 with the CIDR notation 19, we know that this is Class B IP address and this is not a default subnet mask. So how do we know this is Class B? Looking at the first octet, 172 falls into Class B network. And the default subnet mask for Class B network, as we talked about previously, it is 255.255.0.0. So this /19 means we have 19 bits turned on. It's a network bits, which is not going to be 255.255.0.0. Let's find out. So 19 bits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And the rest of them, it's 0. So for Class B, default subnet mask is 255.255.0.0. It's basically the cut line is here. We have 8 bits turned on. Converting this binary to decimal, it's 255. It's basically adding all these decimal values because all the bits turned on. And this one the same. It will be 255 as well. And here we have only 128 turned on, 64 turned on, and 32 turned on. As we can see here, 1 represents turned on network bits, 0 represents host bits. So when we convert this binary here on a third octet, 111000000, converting to decimal is 224. So here 8 bits, that's 255. Dot here 8 bits, 255. Dot here only these 3 bits, that's 224. And here all the 8 bits turned off, so that's 0. So this /19 gives us 255.224.224.0. Therefore, the original default subnet mask, the cut line was here. It did move to the right. Now it's here. So let's erase this one. Okay, so when we talk about subnetting, here you can see that the cut line moved to the right. And we borrowed 1, 2, 3 bits from the host bits. These 3 bits that we borrowed from the host bits known as subnet bits. So here we have 1, 2, and 3 subnet bits. All the ones here represent network bits and 0s host bits, the ones that we borrowed from the host bit known as subnet bits. And we talked about if we want to find out the number of subnets, it's basically the formula 2 to the power of subnet bits. In this case, 1, 2, 3 subnet bits we have. 2 to the power of 3, which is 8. Also, we talked about if we go from left to right, starting at the bottom with number 2, 4, 8, that's another way to find out the number of subnets. And if we go from right to left, starting with 2, 4, and so on till here, and then -2, we will find out the number of hosts per subnets. So what was the formula for the number of hosts? 2 to the power of host bits -2. Why -2? Because one address is used for network address and one address is used for broadcast address. We cannot use it to assign to the computers on the network. It's mainly reserved for the network address and the broadcast address. That is why we have to do the -2 in order to get the total available IP addresses. So how many host bits we have? Zeros represents host bits, which in this case we have total of 13 zeros. So 8 plus 5, that's 13 zeros. So 2 to the power of 13 minus 2, which is 8192 minus 2 is 8190. So this IP address with the subnet mask of 255.255.224.0, we will have 8 subnets. Every subnet we will have 8190 available IP addresses per subnet. And as we talked about here, the number of available IP addresses, if we go from right to left, starting at the bottom, starting with number 2, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 81, 92, minus 2, 81, 90. That's total number of available IP addresses per subnets, and here we have total of 8 subnets. So these are also another way to find out the number of subnets and the number of available IP addresses per subnets. So now to calculate the subnets and be able to find out all the subnets, what we have to do. So after converting the subnet mask into the binary, which in this case they gave us the IP address and the CIDR notation. So we just had to draw 19 bits because this 19 is the number of network bits. So going from left to right, 19 ones, and then draw a cut line and the rest of them 0. Or if they gave us the subnet mask, we just need to convert the subnet mask into the binary. The first octet 255, when we convert it to the binary, all the 8 bits turned on. Second octet 255, when we convert it to binary, all the 8 bits turned on. The third octet 224. So the decimal value of 224, when we convert it to binary, it will give us 111,000,000. Again, in previous videos, we talked about how we can convert decimal to binary, how we can convert binary to decimal. Please make sure you watch those videos. And then on the last octet we have 0, decimal value of 0, when we convert it to binary is 8 zeros. So after finding out our cut line, then we need to pay attention on an interesting octet. The octet that we have the combinations of ones and zeros, it's basically the last octet in the subnet mask that contains ones. In this case, in this subnet mask, the last octet that contains ones, it's this octet, which is the third octet. So this octet known as interesting octet. That's basically where we have the cut line. It's this one because we have 19. When we count 8 plus 8, 16, 17, 18, 19. That's the cut line, the rest of them 0. So the third octet known as our interesting octet. That's the first step, to find the interesting octet. The second stage, we need to find out our network increment or block size. How can we find out? Well, if I put it in the easy word, simply the last bit that is turned on, we have to look at the decimal value, in this case 32. That's our network increment or block size ID. Or on an interesting octet, when you convert the binary to decimal, in this case is 224. And we have to subtract it from 256. So 256 minus 224, which is 32. And the 32 is our network increment or block size ID. Or again, you can just take a look at the last bit that is turned on, in this case this one, and the decimal value 32. That's the network increment. Then we have to find out the zero network. How can we find out the zero network or the first subnet? It's basically we have to turn off all the borrowed bits. In this case, which ones are the borrowed bits or the subnet bits? These are the borrowed bits. So on a borrowed bits, we have to turn off And then just write down the IP address that in every octet we have all the bits turned on. So if we turn off these bits, we will have only the first octet and the second octet all turned on after turning off the borrowed bits. Therefore, looking at the IP address, the first octet we have to write it down, and the second octet we have to write it down. The rest of the octets we have to put 0. And actually in this case they already gave us the 0 network. So let's rewrite it 172.16.0.0. That's known as our first subnet. Or in other words, just basically look at the first octet in the IP address and see what class this is, and then apply the default subnet mask. So this is class B, 172 falls into class B, and the default subnet mask is the first octet and the second octet is the network bits, and the rest of the octets are host bits. So in class B, default subnet mask is 255.255.0.0, so we just need to write down the ones that is 255. In this case, 172 and 16, 00. 255.255.0.0 when we apply the default subnet mask. So anytime when you want to find out the 0 network or the first subnet, you just need to apply the default subnet mask. And then for the host portion, just put 0. So quickly give you guys a couple of examples. Let's say if we have 10.18.9.32, and if we want to write down the 0 network or the first subnet, for example, of course 10, that's class A, so we know default subnet mask is 255.0.0.0. so the octet that it's 0, we just put 0, and the octet is 255, we write down the IP address. In this case will be 10.0.0.0. so this will be our first subnet or the network address. Another example, if we have 172.16.85.35, we know this is class B, default subnet mask is 255.255.0.0. Therefore, the network address or the first subnet would be 172.16.0.0. So for the host portion, the IP address we just put 0. Or another example, if we have 192.168.5.28, we know this is class C, 192 falls into class C range, and the default subnet mask for class C is 255.255.255.0. So for the IP address in the host portion, we just put 0. So let's rewrite 192.168.5.0. This is the network address or the first subnet. So that was our third step when we want to calculate the subnetting. Again, what was the first step? To find out the interesting octet. The second step, to find out the increment, which we talked about, the interesting octet, the binary converted to decimal, and then subtracted from 256. Or the last bit turned on, what is the decimal value? That was the second step. And the third step, to find out the first subnet, which we just talked about how we can find out the first subnet. Okay, after finding the first subnet, we need to find out the next subnet, which we just apply the network increment on a working octet or the interesting octet. So on step 4, to find out the next subnets, we just continue by incrementing using the block size ID. In this case, by 32 on a third octet because the cut line is on a third octet. So the next subnet would be 172.16.32.0. Again, why 32 on a third octet? Because we are working on a third octet and the last bit turned on decimal value is 32. This is our network increment or block size ID. So the next subnet would be 172.16.64.0. Next subnet would be 172.16.96.0. And the next one, 172.16.128.0. Again, 96 plus 32. We all keep incrementing by 32 on a third octet. And so on, it continues. When do we stop? Basically, it will give us 8 subnets. How do we know? 1, 2, 3 subnet bits, correct? The borrowed bits are the subnet bits. We have 1, 2, 3. We talked about earlier, 2 to the power of subnet bits gives us how many subnets we can have. In this case, 1, 2, 3 subnet bits. 2 to the power of 3, that's 8. So we will have 8 subnets. And actually, if we continue incrementing by 32, you will see. To show you, let me erase all this. I'm going to write down here. And the next one would be 172.16.160.0. And the next one, if we continue incrementing by 32, 172.16.192.0. And the next one is 172.16.224.0. And actually, it's always good to know that always the last subnet is ending up with the actual subnet mask where we have 224 here. So it will end up with 224. And if I show you 172.16.256.0, so we don't have 256, 224 plus 32, 256. We talked about in every octet, we have the range from 0 to 255. Because of 8 bits, right? Every octet we have 8 bits. So the binary of 8 bits, all turned off, that's 0. Binary of 8 bits, all turned on, that's 255. The maximum value we can get 255. So if we continue incrementing by 32, we get 256. Therefore, this is our last subnet. So now if we count, this is subnet 1, subnet 2, subnet 3, or the third subnet, the fourth subnet, fifth subnet, 6, 7, and 8. This is our 8th, the last subnet. And as we talked about earlier, 2, 4, 8. This is another way to find out. Okay, now let's go ahead and take a look on a couple of the subnets and find out the broadcast address. For example, let's take a look first. Subnets, these are the available IP addresses. What would be the broadcast address? These addresses are our network address. So here, this column network addresses, or all the subnets, and here the broadcast addresses. So the broadcast address for the first subnet, always the broadcast address is one less than the next subnet. So for this subnet, the next subnet is this one less than this would be 172.16.31.255. If we add one IP address, this will be 256. We said we don't have 256, right? So it will be 0, and it will add to the third octet by 1, and it makes the 31 to 32. Here, as we can see, that's the next subnet. Okay, so after finding the first subnet, finding the broadcast address for the first subnet, all the available IP addresses in between, that's the range of all available IP addresses, which the first one is 172.16.0.1, and it goes to the last available IP address in this subnet is one less than broadcast address, 172.16.31.254. Now if we want to find out the range for the second subnet, so this is the second subnet, always it's better to find the broadcast address first. And how can we find the broadcast address? Broadcast address is one less than next subnet. So for this subnet, the second subnet, the next subnet would be this address. So one IP address less than this address would be 172.16.63.255. Now we have the network address and the broadcast address. In between, we can find all the available IP addresses, which goes from the first available IP address, 172.16.32.1, because 172.16.32.0, that's a network address, so the first available IP address would be 172.16.32.1. And it goes to the last available IP address, which is one less than the broadcast address, and it is 172.16.63.254. So earlier we talked about the formula to find out the number of hosts. 2 to the power of host bits minus 2, and here we can see the minus 2 two IP addresses because of the network address and the broadcast address. These are the available IP addresses in between the network address and the broadcast address. So that's why we do the -2. And in this case, how many host bits do we have? 2 to the power of all the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. -2. As we talked about earlier, 8,190 available IP addresses. So here we will have 8,190 available IP addresses. Here we will have 8,190 available IP addresses. Same thing applies on this subnet. We will have 8,190 available IP addresses and so on. So remember, this subnet mask 255.255.224.0 will give us 8 number of subnets, and every subnet we will have 8,190 available IP addresses. I can continue on the next one, next one, next one, and so on. It's exactly the same process. Just on the last one, when we have the 172.16.224.0, the broadcast one less than next, right? Next address would be 172.17.0.0, right? So when we have, let's say this is subnet 8, the last subnet, therefore the broadcast would be 172.16.255.255. And this would be the broadcast address for this subnet. If we add one IP address, it will be 256. We don't have 256, right? So it will turn 0 and add 1 to this. And it will be 256 here, so it will be 0 and add to this. So that's where we see next network 172.17.0.0, which again, this will be completely other network. We will have total of 8 subnets. Subnet 1, Subnet 2, Subnet 3, 4, 5, 6, 7, and 8 here. If we are keep continuing incrementing by block size 32, our network increment. So now if we go through the range, the first usable 172.16.224.1, and it goes to 172.16.255.254. And again, this range should be 8,190 available IP addresses as well. As we talked about the formula, the number of hosts 2 to the power of host bits -2. The number of subnets 2 to the power of subnet bits. In this case, only 3 subnet bits, 2 to the power of 3, 8. 8 subnets, every subnet, 8,190 available IP addresses. I hope this video was helpful. Thank you so much for watching. If you have any question, please leave it in the comment section. And if you haven't subscribed to our channel and you want to see more tech videos like this, please consider subscribing to our channel. So thanks again and have a good day.